Dear students, I hope you are doing well. Today, I'll just explain you states of matter chapter. It is a big chapter. We will discuss in a series manner. Okay, this is the first video. So here, first of all, let us know the importance of this chapter. Right. So the states of matter is very important. If you can see that JEE question every year, one question is compulsory in this chapter every year, and NEET again one question or two questions every year, and for advance JEE advance also one question is compulsory. So which means this is such a chapter where you can give assurance of 4 marks, assurance of minimum 4 marks for your JEE or NEET or IIT exam. So this is a very important chapter, and this is also useful in physics also, because in physics also you will see kinetic theory of gases, and there also the states of matter chapter will come over there. Right. Now, so matter, if you talk about matter, yes, we all know that matter exists in 3 states. Yes, solid, then liquid, and gas. Right. These 3 states at room temperature. But if you go for the high temperature, there are 2 more states are possible. Yes, that is a plasma state and Bose-Einstein condensate. We call BE condensate. But these 2 states exist at only high temperature. These are existing at a high temperature. So we are talking about room temperature. So at room temperature, matter exists in only 3 states at room temperature. So now the chapter states of matter, here I'm going to explain you about 3 states. The first, in class 11th, it is a gaseous state and liquid state. These 2 topics are covered in class 11th, and solid state chapter will be covered in 12th. So in these videos, what I'm going to try is I'm going to explain about gaseous state. Right. So the topic is gaseous state. Liquid state will come at the end of the chapter. Yes, in gaseous state, we mainly deal about 4 factors. We mainly deal about 4 parameters. So what are those 4 parameters? For gases, we mainly talk about 4 parameters. One is pressure, then volume, then temperature, then amount of substance. Amount of substance means number of moles. Temperature, absolute temperature, so it's a symbol capital T, and volume it is capital V, and the pressure is P. So yes, so the whole chapter runs about the 4 parameters. Keep it in mind: pressure, volume, temperature, and amount of substance. How these are related with each other, that we will discuss by gas laws. Okay, so we are going to study about gas laws. So gas laws means the rules which discuss about the how these 4 factors are interrelated with each other. Yes, we have got 4 gas laws. One is Boyle's law. Next one, Charles law. And the next one, it is Gay-Lussac's law. And the last one, it is Avogadro's law. Okay, so yes, without knowing these laws, you cannot proceed further in chemistry as well as physics. So let us talk about each law in detail. The first one, it is Boyle's law. Yes, Boyle's law is very simple. It states that the pressure applied on any gas is inversely proportional to volume. Pressure applied on any gas is inversely proportional to volume, but condition is, this condition is correct at constant temperature. At constant temperature and fixed amount of substance symbol is n, which is the number of moles. So at this condition only this rule is valid. That's a Boyle's law. Pressure is inversely proportional to volume. Yes, what does it indicate? If you increase the pressure, volume will be decreased, and if you decrease the pressure, volume will increase. Yes, this is simple Boyle's law statement. Now we can remove the proportionality symbol. We put some constant K by V, so which implies the pressure into volume is equal to constant. So this is a very simple Boyle's law. So if for two cases, if you have different case, then P1V1 is equal to constant, which is equal to P2V2. Yes, this is a Boyle's law statement. P1V1 is equal to P2V2. Yes, what is P1? Yes, it is initial pressure, initial volume, final pressure, final volume. So this is a Boyle's law statement. Now graphs are very important because in MCQs they ask about graphs. Even if you see 2010 IIT question, there is a graph also. Yes, yes, first of all, let us talk about the graph of pressure versus volume. Pressure versus volume. Yes, you can pause the video and you can make the notes also, right? So making notes is very important because just watching video will not give you satisfaction. Yes, pressure versus volume. Yes, what does it indicate? Boyle's law? When volume increases, pressure decreases, but not constantly. That is very important. I'll go in a reverse direction. Volume, I'm decreasing. It means I'm going in this direction. Volume decreases, so pressure will increase, but not constantly. That is the main point. You have to keep it in mind. So here the graph will come somewhat like this. Yes, so here it is not a constant slope. That is what you have to observe. And while you are drawing this graph, the temperature will remains constant. So throughout this one, you can maintain some temperature. Let us say temperature as T1, right? Now when temperature is changed, the graph will also change. Yes, let us say another temperature. Temperature is T2. So the graph will come same way. It increases slowly and here it raises steeply. This is at temperature T2. Now let us take another temperature at T3. So here it will come like this. This is at temperature T3. Now what we have to keep in mind is the plots means graphs are called as isotherm. We call these plots as isotherm because temperature is constant while you are drawing the plots. And second point we have to keep in mind is temperature. That is a very important question, can be asked in any kind of JEE or NEET or any entrance exam. Yes, what is the relation between temperature T2, T1 and T3? What is the relation? Which is the greater one, which is a smaller one? So that is the most important question and where students get confused and many times they go for wrong selection. Yes, in that case what we have to do is, pressure is almost same in the both case, in the three cases. Do one thing, you draw vertical lines. Just you draw vertical lines. Okay, so listen carefully. It is a very interesting point and you will not get it anywhere else. So this is a very useful point. Yes, so now you got vertical points For temperature T3, it is a this one, and this is a for temperature T2, it's a volume, and for temperature T1, this is a volume. We will study one more rule in future in Charles law, that is volume is directly proportional to temperature. Understand? We are going to learn one more rule, which volume is proportional to temperature, that we will study further. I don't know whether T1, T2, T3, which one is bigger one, but I know V3 is bigger. If V3 is bigger, then T3 will also be this one. T1 will be bigger. So this is a let me say it's a V3. This is a V2. This is a V1. Okay. Now I don't know which one is bigger one, T1, T2, T3, but I know V1 is a bigger value. V1 is a bigger value means as per this law, T1 is bigger one. Therefore, here I can say T1 is greater than T2 is greater than T3. Yes, this is very important point about graph of Boyle's law. Everybody can draw the graph of P versus V, and you have to keep it in mind. It is a P versus V. Everybody can draw. What you have to keep in mind is 3 points. First point, the plots are called as isotherm because here temperature is a constant. Second point, it is about temperature, which temperature is a greater one, which is a smaller one. In that case, what I have done is I have extra plotted in a vertical manner, then I got the volume, corresponding volume. In Charles law, we are going to learn volume is proportional to temperature. So I know V1 is a very big value. V1 is a big value means correspondingly T1 will also be bigger one. Third point, I said the graphs they are not increasing systematically or gradually. There is a sudden change in the pressure. Initially it is raising slowly, but when the volume reaches to the end, it raises steeply. Right, it is a Boyle's law statement. We have one more graph also. The another graph related to Boyle's law is pressure versus 1 by V. We know that PV is equal to K, right? So now P is equal to K into 1 by V. Can we write like this? P is equal to K into 1 upon V. Now it is looking as Y is equal to mx. So it means if I draw the graph of taking pressure on y-axis and 1 by V on x-axis, the slope will be K. So y is equal to mx. How it looks like? It's a straight line, right? Understood? So now we are going to draw a graph. We are going to draw a graph of pressure versus 1 by volume. So on y-axis what we should take? Pressure. On x-axis last time we took only volume. This time we are going to take 1 by V. Now y is equal to mx. It's a straight line graph passing through origin. So the graph will come like this. Yes, and when you are drawing this graph, temperature is of course constant. Let us say the temperature is T1. Right, and you can have another graph also at different temperature, that is temperature T2. Now another temperature T3. So these are the graphs. Again, these plots are called as isotherm. Again, the question is which value is high? T1, T2, T3, which one is big? That you have to think. Yes, here a volume is almost same. I cannot compare with volume. What I will do is I'll compare with the pressure. So here I will write the pressure. This time we are extra plotting on y-axis. This is the pressure P1, and yes, this is a pressure P2, which is corresponding to temperature T2, and this is a pressure P3 corresponding to temperature T3. Done? Understood? Now we will study one more rule, that is a Gay-Lussac's law, which says pressure is directly proportional to temperature, which I will explain you in the further topics. So don't worry about it. Now I don't know which value is big, T1, T2, T3, but I know P1 is big value. P1 is big value means temperature correspondingly it is more. So I can say T1 is greater than, T2 is greater than T3. So in this way we can easily solve the questions related to Boyle's law, graph questions. Right, understood this one? So two graphs we have drawn. One is a pressure versus volume, and the second graph is pressure versus 1 by volume. This is a straight line passing through the origin, and the previous one was not a straight line. Now there is another graph, one more graph related to Boyle's law, that is a PV versus pressure. The another graph is PV versus pressure. Yes, what do you think about PV versus pressure graph? So yes, PV is always remains constant. So if you increase the pressure, automatically the volume will decrease. So pressure into volume, it remains constant. So here the graph is again temperature will remains constant, absolute temperature T1. This is a straight line one. So if you want to change the temperature, it will be T2, and here it is T3. Now we have to think which is the high value, which is the small value. Again temperature. So here highest temperature, that is the top one, which is a T3, is greater than T2, greater than T1. So this is about a Boyle's law topic. So I hope you understood Boyle's law. It's a very simple thing. Pressure is inversely proportional to volume and PV is equal to K. Now most of the questions can be asked based on graph only. So take care of graphs. Three graphs: P versus pressure versus volume, pressure versus 1 by volume, and the third graph is pressure into volume versus pressure. This is Boyle's law theory completed. I hope you understood it. If you have any query, just put on the comment box and I'll get back to you and I'll revise you again. And there will be summary also at the end of the topic. So there also you will get clear idea. Now next one, it is Charles law statement. Second statement, it is Charles law. Yes, Charles law, he was working on hot air balloons. This person was working on hot air balloons. So in that hot air balloons, yes, what he noticed that temperature, when you increase temperature, volume will be increased. It's obvious, but it's same thing. Temperature if you increase, then volume of balloon also increase. Now what he noticed, that's a very interesting thing. Listen carefully, it's a very interesting one. He noticed for every 1 degree Celsius rise in temperature, the volume of gas, I can say volume of gas or volume of balloon, is increased by 1 upon 273.15 times of volume at 0 Celsius, That is a statement which he has observed. That is a fact based one. So let temperature is a 0 Celsius, the volume will be V0. Now temperature we are increasing, let us say temperature is 1 Celsius, so volume will be V1, which is equal to, as per this statement, what will come, tell me, which is equal to V0 plus 1 upon 273.15 times of V0. Understood? So as per the statement, if you increase the temperature by 1 Celsius, then volume of the gas is increased by 1 upon 273.15 times. Now suppose temperature is 2 Celsius, volume will be V2, which is equal to, what will come? Any guess? You have to compare with the volume at 0 Celsius. So V0 plus 2 by 273.15 times of V0. Now 3 Celsius, yes, it is easy for you now. V3 is equal to V0 plus 3 by 273.15 times of V0, and it proceeds it goes on. So what will come? At T Celsius, the volume of gas will be Vt, which is equal to V0 plus T upon 273.15 times of V0. Right. Now, yes, that equation Vt is equal to V0 plus T upon 273.15 times of V0. Now here what we will do is, let us simplify this one. Vt is equal to, here V0 can be taken common, 1 plus T upon 273.15. Now we are still simplifying it. Vt is equal to V0 into 273.15 plus T over 273.15, and from here the new system of temperature is introduced, that is a Kelvin system. So we know that how to convert Kelvin system into degree Celsius. How to convert a Kelvin system is equal to T in degree Celsius plus 273.15, that we are knowing, but how the 273.15 has come? So from here they said 273.15 plus T, which is equal to temperature in Kelvin system. So I can write Vt is equal to V0 into temperature in Kelvin system, that is a capital T, for T degree Celsius. Temperature in Kelvin system for T degree Celsius upon, it is the temperature in Kelvin system for 0 Celsius. I can write T0. So here capital T is called absolute temperature. Capital T is called as absolute temperature, which means temperature in Kelvin system. Temperature in Kelvin system. Yes, so now from this I can write Vt upon V0 is equal to Tt upon T0, which implies I can say V is directly proportional to capital T. Yes, from here I can make a Charles law statement. So here the Charles law statement can be initiated. Yes, what can we say? Volume is directly proportional to absolute temperature, but condition is at constant pressure and fixed amount of substance, that is a fixed number of moles. So Boyles law, that is a constant temperature, and here it's a constant pressure, correct? So now here we have to take 3 points in consideration. So point number one, or I can say point number A, that is the lowest possible temperature, the lowest possible temperature for any gas to exist is either minus 273.15 degrees Celsius or 0 Kelvin. Below to this temperature gas will not exist. The question is why? Sir, why is it so? Now yes, we take this equation. This equation is our final equation. Keep this in mind. This is the equation number 1 or equation main point. Yes, from that equation Vt is equal to V0 into 273.15 plus T divided by 273.15. Right. Now suppose if we put temperature is equal to minus 273.15 Celsius, implies what volume will come? You tell me. So put the value Vt is equal to V0 into 273.15 minus 273.15 divided by 273.15. So here it is cancelled 0. So implies Vt is equal to V0 into 0. So which is equal to 0. It means at this temperature, which temperature? 273.15 Kelvin. At this temperature, the volume of gas is becoming 0. You can see it clearly. The volume of gas becomes 0. What does it mean? It means gas does not exist at this temperature. Exist at this temperature. So it means, in fact, the gas must have been liquefied before to this temperature. So before to this temperature, it is a very very low temperature. So before to this temperature, all gases will be liquefied. So that means at this temperature no gas will exist. So this is going to be the lowest possible temperature for any gas to exist. This is a Charles law, point number 1. Now next we have to draw graph. Now before I draw graph, the statement I'll write: volume is directly proportional to temperature, absolute temperature. You cannot say simple temperature. So V is equal to K into T, which implies V by T is equal to constant, which implies V1 by T1 is equal to V2 by T2. Yes, this formula we use in Charles law numericals, where V1 and V2 are initial and final temperature, final volume, and T1 and T2 are initial and final temperature. So 1 is standing for initial condition and 2 stands for final condition. Okay, initial volume, initial temperature, final volume, final temperature. That's fine. Now graph, we have to draw the graph. Yes, that's the point number 2. The graph is volume versus temperature. So you can see this is a very clear. V is equal to KT. Again it is looking as Y is equal to mx. So Y is equal to mx graph. How it looks? It is a straight line, right? Straight line passing through origin. So on y-axis what should we take, and on x-axis what should we take? Just think. On y-axis we should take volume, correct? And on x-axis we should take absolute temperature. Absolute temperature means temperature in Kelvin system. Temperature in Kelvin system. So yes, how it looks? It's a graph, straight line passing through origin. So passing through origin. So this is the graph. And here what is a constant? Pressure is constant. That's why I should say it is a P1. And if you change the pressure, the graph will be somewhat different. Yes, this is a at pressure P2. Or if you change some more pressure, so it looks like this, pressure P3. So these are the, and here temperature is 0 Kelvin here. You may ask me, sir, why you have drawn dotted lines here? Because I said gas does not exist at this temperature. Gas does not exist at this temperature. Just now we have studied. In fact, all the gases must be liquefied at this temperature. That's why I have put it dotted lines. That's right. Now you have to think, what is the relation between pressure P1, P2 and P3, point number 1. And here pressure is a constant, so these plots are called as isobar. Point number 1, these plots are called as isobar because pressure is constant. Bar is the unit of pressure. Now pressure, which one is more, P1, P2, P3? I don't know which is a more value, but I can do one thing. I can extra plot on y-axis. I can make horizontal lines. Yes. And I can see this is the volume V1, It's a volume V2, it's a volume V3. I don't know which pressure is high, but I know volume V1 is more. And right now we studied Boyle's law statement that pressure is inversely proportional to volume. So here V1 volume is a more, which means the corresponding pressure must be less, correct? So you can say P1 is less than, P2 is less than P3. So this is about Charles law statement. So we studied two things, and that is a very simple thing. One is Boyle's law, pressure is inversely proportional to volume, and Charles law, volume is directly proportional to temperature. Yes, this is the graph related to temperature on Kelvin system, but there might be a graph if they ask in degree Celsius. Degree Celsius means somewhere it is a 273.15 will come. So this will be my y-axis. This will be my y-axis when temperature is given in degree Celsius, because at that case the origin point will be 0 Celsius, which is equal to 273.15 Kelvin. So the graph will not start from here. Graph will start from here. So take care of these things, my dear students. So because you have to look at the graph, whether graph is asked about Kelvin system or Celsius system. If Kelvin system, it will start from here. If it is a Celsius system, it will not start from origin. It will start with some intercept value, right? So thank you guys. It's a half-an-hour video. Yes, continuation Charles law and Gay-Lussac's law and Avogadro's law I'll explain you in my next video, and there will be some summary also. And keep showing your love and give me some suggestions, feedback. This is my first video, so obviously there might be some hiccups. Yes, in next video I'll give you my best lecture. Thank you guys. Thank you. Take care.